I'm Marilyn. I'm a PhD student in the MISE lab.
Hi, I'm Dang. I'm undergrad of MISE.
So in this video we will introduce you to the topic of data recording and experiment notebook best practices. We will give you some suggestion on how to record data in the lab and during fieldwork, and what is suggested to do and don't during the process. Data is the result of parallel investment of time, people, and equipment, and one of the most valuable resources your lab has. A dataset includes all the information required to repeat the experiment and the resulting data reported from that experiment. It has improved workflows, ensure quality records, and troubleshoot reproducibility issues. For this reason, it is extremely important to record them correctly, especially when they are shared for example in a lab. A good way to do this is to keep a lab notebook. A laboratory notebook serves for this purpose as a permanent record of data and observations for the lab. It also prepares for upcoming experiments, enhancing efficiency, organization, confidence, and safety in the laboratory. And it also serves as a source of information for colleagues who may be interested in continuing a research project. A lab notebook is not a personal journal. It is a comprehensive record of procedures, reagents, data, and thoughts for researchers to share, and it belongs to the institution for which you work. While you have the right to make photocopies of your work, it is not yours. It can be considered even a legal document that records the research claims, result, and background information. It is crucial for patents and defending against fraud allegations. A well-maintained lab notebook serves as a scientific legacy, allowing future generations to build your work. There are three main types of lab notebook: the bound notebook, or the classic one, the ring binder notebook, and the electronic notebook. The advantages of the bound notebook is that you don't risk to lose pages and it's legally stronger. The binder is more organized, and the electronic notebooks are becoming more popular due to their ease of use, legibility, and easy searchability. However, they also have disadvantages. The bound notebook is not logically organized and often require references. The binder is hard to authenticate because you can take pages off, and the electronic ones also require electronic security. There can be corrupted files, there can be software compatibility issue, and you risk to lose data. If you're more interested in this topic, in the topic of electronic notebook security, you can check these papers. So now let's see how to make the initial setup of the notebook. First thing, write your name, the lab, and the email on the cover. Optionally, include contact information on the inside front of the cover in case you lose the notebook. It's important to number all pages in order on both sides, front and back. Create a table of content on the first page where you can write all the contents of the notebook. Leave a few pages blank for the future entries on the table of contents. You can also include columns for the date of experiment, the experiment title or experiment number, and the number of pages there. So let's now focus on the best practices to follow for each entries. For each experiment, you can write your name if more than one person is using the notebook, the date in chronological order, the title of the experiment, the name of the sample, the methods you're using, and the goal, and all the relevant details. Don't forget to explain in non-standard abbreviations so everyone can understand them. Always report mistakes, but data and outliners, as well as the corrections and every useful observation to make the next experiment easier. If you're using a standard protocol, you probably don't need to write it all the time, but you can put a reference and write any difference from the standard protocol. Always include bad results. This is very important because if you know what went wrong, what didn't work, you won't make the same mistake the next time, so you will save time and reagents.
Okay, I will explain about field notebook. As for the lab notebook, similar consideration can be done when it comes to field journals. In addition, you can add sites, weather, hazards, and ocean conditions of the sites you are sampling. In short, tips may seem pointless, but it becomes absolutely necessary during longer tips. Separate your observation and interpretations. These should be kept separate for a very practical reason, namely that your interpretation could be wrong or disagree with someone else's.
So once we have recorded our data in the lab notebook, we have to import them in a data form for further analysis, like in Excel. What is the best way to enter this data in a Microsoft Excel file to make it easier for you to analyze? This is not meant to be a tutorial due to time limitation, but I want to show you a few tricks and features of this software. So once you have import your data, you can add, for example, columns and rows as you please. You can change the color of the cells as you like to make it easier for you to read the data. Some unuseful features you should know is to freeze the first column or the first row. You can just do this, go to view, if it works, view, freeze panes, and freeze top row, for example. In this way, it's very useful when you have tons of data. Even if you move your file, the top row is gonna stay the same. Another thing you can do is to insert a table, like another header. Like in this case, it can be more easy for you to visualize the data. Another useful feature that Excel has is are pivot tables. So to create a pivot table, you can select your table, go to Insert, Pivot Table, create in a new worksheet. The pivot table is gonna look like this initially. We can rename it Pivot just for the occasion. When you click on your pivot table, it's gonna show you the fields of the table, and you can play with it. It really depends on how do you want to see the data, what do you want to highlight. So like in this case, let's see that I want to see which taxa are in which correspond to each sample. So it automatically creates a table of that can show your data in the best way. There is a lot to say about this, and we don't have time, but we can talk about it later if you want. The last feature that I want to show you is how to create graphics. So like in this case, let's see that we have a simple table like this, where and we are on the columns, we have all our families and different microhabitats. In the row the family, and in the columns the microhabitats. So if you want to create a graph, again, you can select the table, go to insert, and then here you have a few options. You can select the ones that you prefer. It depends on what can show you or what do you want to show. Like in this case, I selected this one. Again, you can play with your data and with the table. You can here change the type of and the color of the table, and also change the switch columns and columns. It depends on what do you want to show. Finally, when you want to import your dataset in another software, be sure that the data can be read by this other software. In this example, we have a list of sites and their respective coordinates. If we want to import this data, for example, in QGIS, we have to be sure that the format cell is correct. When you copy-paste the coordinates, sometimes Excel will show the numbers, the data in the number category, so you need to change that to text. If you don't do this passage, when you try to import the dataset on QGIS, the software won't be able to read this information, and it will result in an error of the software. So let's be sure that you don't skip these passages. So this was a summary of Lab and Field Notebook use and best practices and data entry. So basically, the concept is the more organized we are, the easier it will be to organize also our data, and the more replicable our experiments will be. So thank you for listening. Thank you.
Bye bye.
And please ask us any question.